This is a comparison between full tillage corn and no-till corn. And today in this video, I will be discussing kind of what I see in this photo and explaining all the very different precise things that make, I guess, the difference between these two crops. So I'm not going to have this photo up here for the whole time. We'll be using this diagram for now on. Now, I took this photo during my visit to America to see what the Yanks are up to. I was traveling around with Dale Strickler from Regenerative Wisdom. So if you're an American farmer wanting a regenerative consultant, go check out Dale. Fantastic guy. Likewise, if you're an Australian farmer, you can work with me. I consult with farmers, Australian farmers, as to how we can transition your farm to regenerative practices, reduce inputs and do all that good stuff. But anyways, we're looking at the difference between a full-till corn and no-till corn. I'm sure you can see the massive difference in terms of the plant health and structure, as well as the soil health. But the first thing I really noticed when I looked at these two paddocks, actually before we get into that, the two paddocks were basically opposite side of the road. So you had a full tillage system here and a no tillage system here. Same everything, same planting date, same fertiliser program, exact same everything, just this was full tillage, no till. So the first thing I noticed when looking at the different paddocks and different soils was the colour of the soil. And so here's a close up as to the corn's roots. The no-till corn, which is this one, has a lovely, really dark colour to it. You can see in the photo, there's a nice, really dark colour, whereas the full tillage corn is very light colour to it. Now that really reflects the amount of soil organic carbon in those soils. And the dark colour really comes from humus. Now, if you want to learn more about humus, we have a full soil organic carbon course on our website as well as on our YouTube. It's completely free and there's no email opt-in as well. So it's completely free. Go check it out. You learn so much about soil organic carbon as well as how to sequester it. But anyways, there's so much more humus and soil organic carbon matter in the no-till corn than the full-till. And you can really just see that with colour as well as smell. Like when you smell the soil, it smells really dark and not dark but earthy. What soil should smell like. Now with this darker colour, you would expect a higher water holding capacity, a higher cation exchange capacity, as well as a higher anion exchange capacity. So really more nutrients, more water. And to imagine how that would reflect in the outcome of these two corn crops would just be amazing. Like if this went to a drought, the no-till corn would have so much better chances of surviving just because there's a higher water holding capacity than the no-till corn. So the soil's completely different, so much more healthier on the no-till side. Now with the increase in soil organic carbon, you get an increase in biological function, so decomposition as well as nitrogen fixation from free-living microbes, as well as disease suppression. And so a few studies that I looked at during my honours when looking at cover crops and how they affect soil health is that every time you plough up, or when you plough up over a long enough time frame, you effectively reduce your soil organic carbon by half. So half the amount of labile carbon, it rapidly oxidizes and is released to the atmosphere, which is really reflective in these two crops. So the no-till corn here, they're not oxidizing all their soil organic carbon, whereas the tillage corn is constantly oxidizing their soil organic carbon and losing it. Now you can see the photos as well as everything I've written up on our website. I've written up a little article there, so if you want to go see the photos again, go check it out on the website. We have everything written up for your ease. So that was the first major difference I saw, and that was soil colour. The second thing I noticed that was a massive difference was the size and shape of the root zones. And so, as you can see again in the photo, the no-till corn has almost 8 times the size in root space. So if you think about all of this space versus this space, the no-till corn is so much better. Now, what interests me in this side of things is if you have 8 times the root size and area, you effectively have 8 times as much available water and nutrition. So imagine again, in drought situation where you know how much water, which crop is going to pull through, and it's going to be the no-till corn, just simply because the soil was a lot more permeable, softer. You weren't ploughing it up, creating this hard pan, which for the full-till corn was about here. It allowed the roots to really go through the soil and expand. So write that down, larger root system. The third thing I found that was really interesting was that the no-till corn had a lot of root hairs coming off the main roots, whereas the full-till corn basically had nothing. It was effectively bare in terms of root hairs. Now, root hairs is a good sign that the rhizophagy cycle has started, has somewhat activated, or the plant is looking for, is searching more for nutrition. To such an extent that it was really difficult pulling out the no-till corn compared to the full-till. The full-till you could really just pull out one hand. The no-till corn you have to really pull it up. I think we may have had to get a shovel out. But anyways, it was just the vigorness of this plant, or the vigor of this plant, was just amazing. So we'll add that down, root hairs. The fourth thing I noticed between these two plants, and this is so important for plants, is the shape, the color, and the width of the leaves. So the no-till corn had thicker leaves, they were dark green, and they were really long. Now, this is quite important because the amount of leaf space we have allows for our plants to photosynthesize at a greater ability. And so simply if you have more solar panels on your roof, you're going to capture more light. Same things for plants. If you have more leaf area, then you're going to be able to capture more light. The other thing is color. Now color, especially that dark green color, is indicative of chlorophyll content in the leaves. Chlorophyll is what actually captures the light. And so you have a really dark leaf, it means you have more chlorophyll packed into that leaf, making it more efficient. Now, in the full-till corn, it was a lot paler, it was a lighter color, meaning that chlorophyll content wasn't packed into that leaf. So when we compare these two, now I didn't have a bricks reader, that would have been really good to know how much sugar those two plants were producing, but I would have guessed that this one so much more than the full-till corn. So an increase in photosynthesis means an increase in carbohydrate production, which means when it comes to grain fill, our no-till corn is going to significantly outcompete our full-till corn, just because so much more energy is being pumped into those kernels, producing a bigger bigger thing of corn. The other thing is that this corn plant will be sequestering carbon at a greater rate than our full tillage corn. And so our no-till corn is going to be stimulating the microbes a lot more. Just really everything's pumping those sugars into the root zone. Now, the darker leaf color is likely due to an increase in nitrogen content, magnesium content, and iron content, all of which are increased in no-till soils. And that's due to the, or for magnesium and iron, and manganese, actually, sorry. That's going to be due to a reduced soil environment. So the minerals are going to be in an available form for our plant. Whereas in our full tillage corn, all those nutrients are going to be in the oxidized form, unavailable to our plant. Likewise, our nitrogen is going to be held better in our no-till soil as it's not broken apart, oxidized and released. So that was longer, wider and darker leaves. The next notable thing I saw was the stem diameter. And so if you think about the pipes you have in your house, a wider diameter on your plant is going to allow for more nutrients and water to go into the top of the plants, into the leaves. And so effectively the no-till corn had a much thicker diameter than the full-till corn, simply further showing that the no-till corn was just a much more healthier and vigorous corn plant. The other thing that's important with this is that the larger stem diameter is going to allow for the corn plant to hold onto a larger crop or larger grain, which is really what you want. Bigger the yield, the better. Now it's also important because our corn plant here is going to be photosynthesizing at a greater rate, which means sugar production is going to be maximized or at least increased. So those sugars need to go somewhere. And during the vegetative stage, the corn plant will pump those sugars from the leaves down to the roots and as root exudates. So it's very important that we have a large pipeline in our plants to be able to move those nutrients back and forth. Likewise, during the reproductive stage, the plant's going to be drawing those nutrients back up from the microbe pool into the grain, improving the grain fill. Now, unfortunately, the full tillage corn didn't really get any of that benefit. The stem diameter was quite small. So definitely, no-till corn, so much better. The next thing I saw were aerial roots, which are these here. These roots that come from the stem of the plant and go down into the soil. Now, an interesting thing about aerial roots is that they produce a mucus which actually support nitrogen-fixing bacteria, of which can actually supply the plant with a lot of nitrogen. There was a study on that. You can check it out on the website if you go check out this article. Everything will be in the description below, so go check that out. But anyways, this has the potential to be fixing nitrogen for the corn plant because it's formed symbiotic relationship with free living nitrogen fixing bacteria. So to think about the nitrogen benefit you'd get from that, I'm not too sure what it is in kilos per hectare, but it would be even anything would contribute to yield. So we'll add that onto our diagram. So 2 more to go. The next one, number 7, the 7th thing I saw was simply just the height. The height of this corn was a lot higher, or a lot greater. Speaking to just the healthier corn plant, you can put more of that energy into growing a bigger plant. And now the final thing I saw that was really noticeable was soil structure. Now I couldn't really represent it here, but again, if you check out the photo, the soil structure on the no-till corn is a lot more crumbly. There's actually structure there. So this is important because it allows for gas and water exchange. I would imagine that the no-till corn would have a greater infiltration rate, furthering the benefit it would get during a drought time. So if you have a soil that can capture all the rain you got and doesn't have any runoff, then you can prolong or you can recharge your soil to a greater extent during a rain event. And it seems like recently we're getting more and more heavy rainstorm events, meaning it's super important that we have healthy soils to capture all that rain. Now, on the other hand, the full till corn really didn't have any soil structure. It was super blocky and compact. It was very massive. So this is going to be bad because it doesn't allow gas exchange, which is needed for root development. Likewise, you can probably see that here. The roots are impeded. It's not allowing the roots to really grow out and around. Versus our no-till corn here, the roots are prolific. They're just everywhere. Soil structure is also quite important for access back onto the paddock after a rain event. Having good structure will allow you to get machinery back on if you do need to, say, plant or spray or do whatever you need to do. The no-till corn here will allow you to go back into the field days before your full-till neighbour. And so I'll add that in as a last point, soil structure. So there we have it. I would expect that this farmer here practicing no-till would massively outperform our tillage farmer here. In addition to outperforming, this farmer is going to be preserving their soils. They're going to keep it. It's not going to run off. Their water's not going to run off, reducing erosion, making sure they can actually farm into the future sustainably while making hopefully more profit. So when I went over to America, it was really interesting to see that actually so many US farmers still use tillage. Coming from Australia, where 92% of our farmers are no-till, it's quite crazy to see that 70% of the US farmers are still actually ploughing and tilling their soils. And I think just this demonstration and what I saw there just really drives the argument home as to the importance of looking after your soil health and going no-till. Again, it's important not to be too dogmatic about these things. If you do need to till, then these things happen, especially in the organic farming space where you're not using herbicides. Everything has trade-offs, but it's important to know what you're trading off and doing things so that you can improve your soil. Anyways, that's it from me. If you're a farmer in Australia, specifically New South Wales, but we work with all farmers from everywhere, and you want to, or hopefully you're the 92% that are no-till, but if you want to take that further using cover crops, microbial inoculants and nutrition, rather than using pesticides and whatnot, you get in contact with me for a free 30-minute consultation, and I'll see how I can help you do that. Awesome. Thanks again for watching. My name's Till. Cheers.